Hello, in this video we're going to have a look at calculating the area of a triangle. Now we should all be familiar with calculating the area of a triangle when it's got a right angle as a half times base times height. But in this example we're going to look at calculating the area of any triangle, so non-right angled as well. To do this we're going to have to use some trigonometry. Let's take a look at the formula. The formula for the area of a triangle is a half times side B times side C times the sine of angle A. At this point we should all be familiar with labelling up the triangle, so let's just draw in those. Angle A might sit there, which means that it's sandwiched and adjacent to side B and side C, and it's this kind of setup that you need to look for in any triangle before you start plugging in numbers. Let's take a look at an example. So in this particular example I'm actually given three different sides. Have a think which one of these sides is of no use to me whatsoever. Hopefully you've all agreed with me that this 12 centimeter side is a bit of a red herring. It doesn't need to be in there. I need an angle A, I need a side B, and I need a side C. Now that I've got my triangle labelled up and I've got rid of this bit of information that is only there to confuse me, I can start to work this out. So the area of the triangle is equal to a half times 7 times 10 times the sine of angle A, which in this case is 35 degrees. When I plug all of this into my calculator, I'm going to get a final answer of 20.1 centimeters squared. And just be careful not to forget your units because you are calculating an area. Here are two to have a go at yourselves. Be careful, some of them may include information that you don't need. Pause the video here, have a go at these yourself. When you're ready for some answers, hit play and I'll talk you through both of them. Okay, so in this first one, hopefully you've realised that this 13 millimeters is not actually needed, so I'm just going to cross it out and get rid. Now to work out the area of the triangle, this is going to be a half times B, which in my example is going to be 6, times C, times sine of the angle that they enclose, which in this case is 48. When I plug all of this into my calculator, I'm going to get a final answer of 22.3 centimeters squared. In the second example it's slightly more straightforward. It just has an obtuse angle in the triangle. This doesn't affect my calculation at all. It's still going to be a half times 4 times the 9 times the sine of the angle, which is 105. This will give me a final value for my area of 17.4 centimeters squared. Well done if you got both of those questions correct. Thanks for listening.